Okay, we are moving on to apply our proportional knowledge with similar figures. Similar figures you can define as the same shape but a different size, meaning they look similar. The other thing about similar figures is their angle measures are the same. That's more of a 11th grade standard. You don't really have to know that as a 7th grader. You can just know, hey, if I have this triangle and I have a triangle that looks like it is similar, meaning the angle measures are the same, it's just smaller. It's just smushed it. They are similar. Congruent means same. And we're just taking into assumption that you understand that for similar shapes or similar figures, they have congruent angles. So say angles are congruent. I'd like to at least introduce that to you. Corresponding sides, you need to know what that means. Corresponding sides are the sides of the triangle that are related to each other. So now you draw two similar triangles. And it doesn't have to be triangles. What was I thinking? It can be any shape. So the sides of a shape that are related to each other. So I will show you that it can be any shape. Let me draw a rectangle. Here's a rectangle. I'm going to draw a similar rectangle. I'm going to make my similar rectangle bigger.
Whoa.
Yep, that's what I just did. Okay, corresponding sides. That means you want to know this side is related to the left side over on the other one. The top is related to the top of the other one. The right side is related or corresponds to the right side on the other one. Notice that how I'm denoting the same angle measures. I'm denoting them with bars. 1, 2, 3, 4 is related to that fourth side. Okay, so you must be familiar with corresponding sides because that's how you set up a proportion. What we're going to get to is side is to side as side is to side, just like we've been doing with word problems. Okay, so you want to align your corresponding sides together. That's what I have here. Side is to side as side is to side. Okay, so before we can apply proportions, I want to prove to you that similar triangles are proportional to each other. The definition of proportion is the equality of two ratios. So if you look at these two similar triangles, I'm saying that they're similar, which means they're proportional. I want to just prove it to you. You won't have to do it. But if they're proportional, then I can say AB, 8, is to, what, 12, as, somebody give me another angle measure, 8, side length. Now I got to go back. So I'm going small is to big as, now I got to go to a small. What do you want, 10 or 12?
4.
21.
10. 10.
I'll do 10. As 10 is to, what is aligned with 10?
15.
The 15. And now I'm just going to show they are proportional. So I can use cross product to actually apply and find missing dimensions like we're going to be doing. To identify if things are proportional, their cross product must equal each other. So does 8 times 15 equal 12 times 10? Well. Yes, it does. 120 does equal 120. So similar triangles or similar shapes in general, if they're similar, they are proportional. Proportional means that you can do cross products and solve with the cross product and creating a proportion. And that brings us to the next page. Now what we're going to do is apply our proportional knowledge and find missing side lengths of similar figures, not just triangles. You're given rectangles, squares, triangles, hexagons. You're given all kinds of stuff. Just similar figures. What you want to do is set up a proportion, and then you just solve it, just like you've been doing. How you set it up, go side is to side as side is to side. You choose how you want to set it up. There's so many right ways to do it. You could also do big is to small as big is to small. Doesn't matter. You could do small is to the big one as small is to the big one. It doesn't matter. What matters is that when you make that decision how you're going to compare, you continue doing that for the next one. So looking at these two triangles, I'm given that this right triangle is similar to this little right triangle. So I need to create a proportion because I want to know what is x. What is x? And I can find x by creating a proportion. So somebody give me a number. Just pick a number to start at. No. The number has to be aligned with the triangles. 13, 10, x, or 6.
10.
I heard more 13s. So I'm going to say 13 is to what? X. 13 is to x. So I'm doing biggest to small. That's what I just did. So 13 is to x as, now I have to go back. It has to be a pattern. 10 is to 6. 13 is to x as 10 is to 6. Big is to small as big is to small. You have to just follow a pattern. You don't always have to do big is to small. You could have went x is to 13 as 6 is to 10. It would work. Small is to big as small is to big. A lot of my kids, most kids like to say 13 is to 10 as x is to 6. That is the most popular proportion. My brain likes this one better, the first one we did. About 80% of kids make this proportion. It'll give you the same thing. So notice this was side is to side as side is to side. So tall is to the horizontal as tall to horizontal. Whatever you do, just as long as you follow the pattern you choose. Okay? So now I get 10x equals 78. X is 7.8. And if you like this one that most kids like, 13 is to 10 as x is to 6, notice it'll give you the same thing. I'd get 10x equals 78. It would be the same exact thing. Okay, next one. Alright, so I'm given that those two triangles are similar. They're the same shape, just different sizes. That means they're proportional. So I'm going to set up a proportion. There's many of them you can use. I usually just start with the number I'm looking at first. I happen to look at 22. So I'm going to say 22, and I like to do biggest to small. Or left is to right is really what I do. So I'm going to do 22 is to 4 as, now what do I do? X. I go back to the big one. As x is to 7. 4x equals, what, 22 times 7? 22 huh? 154. 154 divided by 4 is 38.5. Hey, you didn't have to do that one though. I bet you a lot of your brains wanted to say 22 is to x as 4 is to 7. It'll be the same exact answer. Any choice is a good choice as long as you follow the pattern you initially choose. Make sense? Inner triangles we're going to skip for now. We're moving on to indirect measurements. So skip to that page. I love indirect measurement. anytime you see a shadow example is anything that is going to be aligned with indirect measurement. Perhaps you remember it from your pre-test. What you want to do is draw a picture. I always make my kids draw a picture. And you do not have to be an artist, because I'm not an artist, but I still draw a picture. And guess what? My proportions are always right because I draw a picture. What I want you to visualize, given these two buildings, can you see the two triangles by chance? Do you see that I have this triangle? And then I have a little baby triangle. Can you see that? That's your goal. Your goal is to get to where you can visualize the triangle so you can create your proportion. However you choose to create it, okay? So, let's say that, well, what are my two triangles? I'm going to start with 50. Or you could start with 8 or whatever. You could start with any of the numbers. I'm choosing 50. 50 is to what? What do you want to do? 8. You want to do the ground is to the height as ground is to height? Okay. 50 is to 8, so you're doing ground is to height. As 12.5 is the ground is to 50. I personally wouldn't have done that. My brain works better going 50 is to 12.5 as h is to 50. But they're equivalent. Doesn't matter, again, as long as you follow the pattern you initially choose. So goal, visualize your triangles. That's your goal. With anything that has to deal with shadows or something angled against a building, you should try to visualize two triangles that you can turn into similar figures. Okay, your school casts a shadow that's 8 feet long. Your friend's shadow is 5 feet, and your friend is 6 feet tall. How tall is the flagpole? Okay, the school flagpole casts a shadow that's 8 feet long. Your friend's shadow is 5 feet, and your friend is 6 feet tall. How tall is the flagpole? So I have a friend and a flagpole. So I like to draw a picture. Here's my flagpole. Here's my friend. Hey, friend. Look at my friend's going to be weird and wear pigtails. Yeah, look at my friend. My friend is happy and my friend's smiling interestingly. Okay, so there's my pic. Now here's my two situations I'm talking about. The flagpole casts a shadow that's 8 feet long. A shadow is on the ground, isn't it? 8 feet long. Your friend's shadow is 5 feet. Your friend is 6 feet tall. How tall is the flagpole? Can you see where the triangle would come? That's what I want you to be able to visualize. The triangle would be like this. Can you see the triangle's neck? And then you can create that proportion however you choose. I'm going to go shadow is to shadow. That's what I'm going to do. So 8 is to 5 as x is to 6. So I'm doing flag is to friend. So 8 is to 5 as x is to 6. You didn't have to. You could have went x is to 8 as 6 is to 5. You could have went 8 is to x as 5 is to 6. You could have worked backwards. Whatever. As long as you choose what works best for you. 5x is 48. 48 divided by 5 is 9.6. My flagpole is 9.6 feet tall.